Let's have a look at some modulus inequalities. So the easiest way for me to do this would just be to do some examples for you. So I'm going to go through question 1 here as an example for you. The reason we call them modulus inequalities, we use the word inequality because of these less thans and greater than signs that you see. And then the modulus symbols, these absolute value symbols, we often refer to as the modulus. So these are modulus inequalities. So let's have a look at this question 1 here. The modulus of 2x plus 1 is less than 3. So what's our method? There's a couple of different methods for solving these. The one I like is where we square both sides, and that will allow us to get rid of our modulus symbols, and then we solve the resulting quadratic inequality. So let's have a look at this. So the first thing we're going to do is we're going to square both sides. Okay, so we just have to square each side out. So starting with the left hand side, let's go to our rough work just to make sure we do that correctly. So we've got 2x plus 1 to be squared. So we know that that means 2x plus 1 times 2x plus 1. So we've got 4x squared plus 2x plus 2x plus 1. 4x squared plus 4x plus 1. So the left hand side we know becomes 4x squared plus 4x plus 1 is less than, and then squaring out the right hand side, less than 9. So continuing on here, that will leave us with 4x squared plus 4x plus 1 minus 9 is less than 0. So in other words, 4x squared plus 4x minus 8 is less than 0. Now this particular inequality here can be simplified if we take it and we divide it by 4. So that will leave me with x squared plus x minus 2 is less than 0. And this right here is a quadratic inequality. Now we've already looked at quadratic inequalities and we know well how to solve them. So we're going to look at that on the next page here. So let's have a look. X squared plus x minus 2 is less than 0. So we know that this means we have some quadratic function, x squared plus x minus 2, and we care about where it's less than 0. So remember, where it's less than 0 is this part down here, and the x values that are associated are the x values in between the two roots. So we need to figure out what are these x values in here, the x values that are in between the two roots. So therefore, in order to describe these x values, the first thing we have to do is find the roots. So let's do that. So we know that in order to find the roots, you put the function equals to 0. So we've got x squared plus x minus 2 is equals to 0. X plus 2, x minus 1 is 0. So x plus 2 equals 0, x equals minus 2. X minus 1 equals 0, x equals 1. So we found our roots to be minus 2 and 1. So that means this right here must be 1, and this right here must be minus 2. Now, to finish the question, we have to describe what these x values are. The answer to the question is the x values for which the function x squared plus x minus 2 is less than 0. And that function is less than 0 for these x values here between minus 2 and 1. So therefore, the actual answer to the question is this function will be less than 0 when x is between minus 2 and 1. So let's look at one more example here. I will go through question 9 here. So the modulus of 2x plus 3 is less than or equals to 3 times the modulus of x minus 3. So same idea again, guys. We square both sides first of all. So you're going to square the left hand side and you're going to square the right hand side. So we have a nice bit of work to do here just in squaring both sides. So starting with the left hand side, I have 2x plus 3 to be squared. So I know that means 2x plus 3 times 2x plus 3. 4x squared plus 6x plus 6x plus 9. So we've got 4x squared plus 12x plus 9. That's our left hand side. 4x squared plus 12x plus 9 less than or equals to, now let's be careful here, we've got kind of two parts to the right hand side. We've got the 3, which is multiplied by the x minus 3. So the 3 is fairly straightforward. We know that the 3 will square to 9, but it's going to be 9 times whatever x minus 3 squares out to. So let's have a look at that. So we have x minus 3 to be squared, which means x minus 3 times x minus 3. So we've got x squared minus 3x minus 3x plus 9. So we've got x squared minus 6x plus 9. So that's what we have right here. X squared minus 6x plus 9. Okay. So we'll continue on then. We'll just do our multiplication and continue on. So we've got our 4x squared plus 12x plus 9. Less than or equal to 9x squared minus 54x plus 81. I like to take everything to the left hand side. So we're going to have 4x squared minus 9x squared plus 12x plus 54x plus 9 minus 81 less than or equals to 0. So that's minus 5x squared plus 66x minus 72 is less than or equal to 0. Now, you see here we have this negative x squared, so we don't like to start with a negative x squared when we're talking about quadratic inequalities or factorizing. So we're going to multiply the whole line by minus 1 in order to get a positive x squared. So that will leave us with 5x squared minus 66x plus 72 is greater than or equals to 0. Remember, when you multiply by a negative, you change the direction of the inequality sign. Alright, so it went from a less than or equals to a greater than or equals to. Don't forget that. You change the direction of the inequality sign when you multiply or divide by a negative. So we'll continue this. We have 5x squared minus 66x plus 72 is greater than or equal to 0. Another quadratic inequality. So we know we have some quadratic function, and we care this time about where this quadratic function is greater than or equals to 0. So that's this part of it here, and this part of it here. And it's an or equals to, so technically including the roots. We know that the associated x values are these x values here, and these x values here. So for these particular x values, the function 5x squared minus 66x plus 72 is greater than or equals to 0. So what are these x values? Well, let's find the roots. So once again, we know in order to find the roots, you put the function equals to 0. So 5x squared minus 66x plus 72 is equals to 0. Let's factorize this. 5x and x factor 72 that we need. We're going to use 12 and 6. 5 12s are 60 and 6 is 66. So 5x minus 6 equals 0. X minus 12 equals 0. 5x equals 6, x equals 6 over 5, or x equals 12. So we have figured out that our roots are at 6 over 5 and 12. So let's put them into our diagram. This must be 12, and this here must be 6 over 5. So then getting back to answering the question, so what is the answer? For what x values is this function greater than or equals to 0? For the x values that are greater than or equals to 12, or less than or equals to 6 over 5. So when x is less than or equals to 6 over 5, or when x is greater than or equals to 12. So that is two examples of modulus inequalities. The best thing for you guys to do now is have a look at some of these examples and check your solutions. And for access to questions, solutions, graded quizzes and more, visit www.limymaths.com.